All right, this is when we get into the really fun stuff. This is really exciting. This is what got me into mathematics. Okay? Linear programming. This section 3.3, this is one of the first moments that I had that got me excited about math. And essentially what it comes from is it comes from this guy in the 20th century who was working for the US military. I think his last name is Danzig. He's called like the father of linear programming, they essentially would have him, find optimal ways of like supply allocations, scheduling for troops, and all this stuff. Just trying to find the best way of doing things, the best way of operating, essentially. And so he really developed this theory in the middle of the 20th century. And programming actually doesn't have anything to do with our concept of programming on a computer. Programming here refers to like scheduling and stuff like that. So that's where that word comes from. All right. I want one more nerd comment. My research that I did in grad school when working on my master's degree is called stochastic mixed integer programming, which is basically just stochastic means a random version of this, and mixed integers means that it can have integers instead of just any real number, which actually makes things much trickier, even though you would think an integer requirement might make things simpler. So we're going to do something not like that, but a little taste. You get some cool problems. So a lot of times in this class, we've talked about maximizing profits, minimizing costs, and we've had some sort of model for this. We're going to up our model. We're going to up our model game. Okay. We're going to say, well, okay, let's have an equation to describe profits. Let's have an equation to describe our costs. And yeah, we want to maximize our profits. We want to minimize our costs. But we can't just produce 5 billion items and become a millionaire. All right? There are constraints. There are supply constraints. There are demand constraints. There are production constraints. There's all these requirements in the real world that we have to follow. So with all those requirements in mind, how do we optimize our profit? How do we minimize our cost? That's essentially what linear programming is. So there's going to be two parts to a linear programming problem. There's going to be the constraints. These are usually inequalities. We can only spend a certain amount of money. We only have a certain amount of time that we can spend working on this. Those are all constraints. We'll also have something called an objective function. And this is what we want to maximize or minimize. Usually it's going to be for us a profit function, or maybe a cost function, maybe a revenue function, something like that. So this is what a linear program could kind of look like. We're trying to maximize this objective function. And we have some constraints. Very often, we'll require things to be non-negative, because a lot of times we'll solve problems that we want to do in the real world. And in reality, negatives make sense, but not in all times. So this is what it's going to look like. Usually, if you can get here, you've done the hard part. A lot of times in this section, the hard part is actually putting it in this form. Okay? And notice what we have right here. This is a system of linear inequalities, right? These constraints that we have, these requirements that we have to follow, this describes a region. And we graphed that in the last section. The last section is super important here. Okay, 3.2, very important here. Okay, and this region that follows all these inequalities is what's known as a feasible region. Where do I say that? I say that over here. Let's look at a problem. Okay, so I gave you, what are we talking about in general? Oh yeah, we want to maximize profit. We got to deal with certain requirements. Here's what things are going to look like. We got two definitions. Let's see this actually using an example from last section. So that's where the company's creating basic products and premium products. And, we described with inequalities how it could, how many different ways it could do that. But now let's look at the new information. They sell the basic products for 30 bucks of profit and the premium products with a profit of $40. So the question is, okay, we know all the different combinations, right? We graphed that in the last section, all the different combinations of basic and premium products that we could make. If this is the case, if this blue underlined new information is the case for profits, what production should we do to maximize those profits? I'm going to do this problem in a couple parts, and then we'll formalize it in the next section. So first, we want to set up the objective function and constraints. What do we want to maximize? Well, remember, right, from section 3.2, we did this before. We said B would be the number of basic items produced. And we said that P was the number of premium items produced. We did that in the last section. Don't need to reinvent the wheel. You can go back into that last video if you want. I think that was one of the later videos. It was example 5 in 3.2.4, if you want to see where those came from. All right. So we got those inequalities, and we found that 20B for assembly and 30P for assembly, those had to be less than or equal to 3,900 hours for assembly. And we also found that 15 for painting the basic and 30 for painting the premium, and we only had 3,300 minutes. We found these inequalities in the last video, or in the last section. Okay, so these are our constraints, along with, again, the requirements that we're only dealing with non-negative numbers. Don't worry, this whole section, not just this video, but this whole section is how to do this. So this is just an overarching, like, big picture video. Say, here's what we're doing. In the future videos, we'll break this process down. So if you're not quite tracking so far, don't worry too much. We'll get more into the nitty gritty in the next ones. This is trying to give you a picture of what's going to happen. So these are our constraints. Remember, I said there's two things, right? There's an objective function and constraints to any linear program. These are the requirements that we have to follow. Yeah, we only have so much, right? We have a constraint for assembly. We have a constraint for painting. And then we have a requirement or a constraint for things to not be negative. So these are our constraints. What's our objective function? An objective function is something we want to maximize. Very often it's profit or cost or something like that. Oh, so yeah, our objective function is going to be profit. We're told that the basic is a profit of 30 and each premium is a profit of 40. Well, if that's the case, then what's our profit? Our profit is going to be $30 for every basic and $40 for every premium. So we want to make this profit as big as possible. Fun little fact, if we did use function notation here, we could write that as P of B, comma. Oh gosh, oh, this is a disaster. I just noticed it. We can't have P mean two different things. That's silly. All right. We all call our profit, I don't know. let's have premium products be like, oh dear. What do I want to do for this? Let's have profit could be little p. That's fine. Big P, little p. That's only mildly confusing. So we could use function notation. Our profit is a function of basic items and premium items. I hope you picked better variables. Or maybe you're just doing what I'm doing and then we're in this together. All right. Profit could be any variable. It could be X, it could be Y, it could be Z, whatever you want your profit to be. Okay, let's move on. Graph the feasible region. Again, we already did that. We did that in the last section. And the feasible region, that's a new definition. It just means the solution to the system of linear inequalities. So these constraints, these form the feasible region. It's called the feasible region because it's all of the inputs that make sense. It's every decision that's feasible. How many basic and premium should we produce? Well, as long as we're inside this region, that's an option. Maybe not a good option, but it is an option. So go into Desmos and we'll graph these. We'll say that 15B plus 30P less than or equal to 3,900. Nope, it's 20 plus 30. And the other one is 15 plus 30. And we'll have to do 15B plus 30P less than or equal to 3,900. And so currently, Desmos doesn't know that these are variables. So I'm going to replace them with X and Y so that it's not confused. And in fact, if you want to just replace them all with X and Y right now, so that we don't have confusion, you could do that. All right, XY, 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 Y, and XY. And down here, XY. And now we don't have to worry about two different P's. All right, so graphing this, wow, this is really interesting. Makes a lot of sense. Go to this wrench icon and let's zoom out. You can also just scroll to zoom out, but sometimes if you scroll to zoom out, it doesn't give you a great picture. Here it's fine. I'm a little, this should be 3,300. I got it nervous for a good reason. And we can see our feasible region is the overlap, right? So this is where they cross. It's going to be this. Let's use colors that work. None of these colors really look that good together. Anyway, the idea is that the feasible region will just be the place that's under both of these lines. And non-negative, right? So X greater than 0, Y greater than or equal to 0. Maybe I don't want to graph these on Desmos because they just kind of make it look messier. We could do this. All right, but this is our feasible region. It's below the blue line, and then we switch to be below the pink line. Everywhere that everything's highlighted. So we did that. Now let's look at different profits. This is where things are kind of weird. We want to maximize the profits. So the profit is 30x plus 40y. Profit is 30x plus 40y. Now what I want to do, now it's not offering me the option anymore, so I'm going to maybe write a capital P. Huh. Desmos is usually pretty good at doing this. I wonder why it's not giving me the option. It gives you the option to add a slider sometimes. Anyway, we can look at different profits. Let's look at, say our profit's 10. That's not very much profit. Let's make a bigger profit. That's not very much profit. Look at what happens is I make this profit bigger. Right? Our profit is this. The profit's the left-hand side of this equation. As I make the profit bigger, the line moves up. And we want this profit to be as big as possible. So if we want a profit of $3,500, we could do any production on this line. We could produce 90 basic and 20 premium. We could produce 40 basic and 57.5 premium. Okay, that one doesn't work very well. Anything on this line will give us that profit. We want this profit to be as big as possible. All right, have a profit this much. Okay, so these options, they're not feasible. We don't have the hours to do these options. We're not in the feasible region anymore. But down here, we are still in the feasible region. We can get a profit of $5,500. We're in this feasible region. We want to maximize this. There are a bunch of options for doing this. Let's get a profit of $65. Oh. All right, a profit of $6,500. That's not possible anymore, right? There's nowhere in the feasible region that we can be on this line. There's nowhere in the feasible region that we can get a profit of $6,500. And that's essentially what we're doing here. We're just trying to find what's the biggest profit we can do. Can we do 6,000? Almost. Not quite. And that's how we're going to solve this. I don't remember what the actual optimal is. I think it's getting really close to this. Close to 5,800 is close to our maximum profit. And it's going to basically be over here. So one of the ways to graphically think about this section is we have a feasible region. We have this profit function we're trying to maximize. So we can just keep increasing the profit until see when we hit. And we've got some theorems, some math behind the scenes that's going to tell us an easier way of doing this instead of just graphing a bunch of lines on Desmos. So how can we systematically find this best line? And again, our guess from this graphing is maybe about 5,800. You know, maybe our max profit is about $5,800. And that's going to, I don't know, maybe occur when we make about 193 premiums or 193 basics. No premiums. Make about 193 basics. So the premiums, waste of time. They don't give us enough profit. Just going to make the basics according to this model. In the next video, we'll talk about how to make this, formalize this process. This is the big picture. Well, what's kind of going on? In the next video, we talk about how can we do this and make it not terrible. So watch on and let me know if you have questions.